So I'm very happy to be back in Split. I was there last year to present how you can connect to create 3D content for the HoloLens. And this year I'm coming with two friends. So Tarik from Amazon, and Tarik will introduce himself in a few seconds, but what we're going to explain you is, while it's fairly complicated to write a web app, it's even worse when you have to deploy it on the internet through different cloud services, but to make it secure, retailable, seamlessly deployed onto the web. And we'll try to explain you the challenge on how we address that with our friends. So Tarik, can you introduce yourself quickly?
Yeah, so Tarik Makota, I'm with Amazon Web Services. I don't sell books. We do cloud. So I'm actually partner solutions architect working closely with Autodesk. So as Cyrille said, we'll try to make this entertaining, try to make it educational, and we hope you enjoy it.
Yeah, so as you notice, we had a little issue to start, but I hope everything will go seamlessly for the rest of the presentation. So I say we are actually three friends on stage. So the next one is actually is not on stage. So Alexa, where are you?
I am right here.
Oh, great. She's right there. So we're trying to use that device to help us to deploy on the web, on the Amazon Cloud Service. So this device is actually an assistant, so you can ask any kind of questions, and she will try to understand what you're asking, and she learns what you're saying, so through skills, and we have developed skills to help us. So let's move on and explain you what we're going to try. So we are going to use the Autodesk technology, which I briefly introduced last year, which is the Forge Web Service. So Autodesk develops this service to consume 2D and 3D content you create through different software, but to use that content on your mobile and web application. So you can really get 3D information and make an application from that. So last year, I was talking about how you can bring that content to HoloLens, but you can recreate different applications where you consume that information. So it's not only about geometry. It's important to understand that you consume all the information associated with a 3D model. So it could be a building, it could be manufacturing. It's really up to you. And you develop your applications through that system. And our web service are actually running on the cloud through the Amazon Cloud Services on infrastructure. So we have different API, but I will just go quickly through them because it's not really what we want to show you. It's about consuming 2D, 3D content instead of having proprietary file format, we just allow you to connect to this information through JSON payloads or PNG or something you can read, which is like more open for the web. And you can consume and ask the service to provide you this information through filtering on selecting objects you want. So, as I said, we deployed Autodesk Forge series through Amazon, and there are a couple of reasons for that. The first one is fast deployment. What does it mean? While Autodesk have their production server deployed on Amazon and we have a DevOps team working on that, any employee at Autodesk could, at any stage of the project, deploy their own server and test things. They can very easily deploy an app, test the app, shut down the system, so they can try live, per se, what they're doing. Low cost. So Amazon Web Service, I would say, is not expensive, but they're taking a lot of money from us. And we try to get this to the low cost. So that's a nice thing, because actually Amazon helps you through their service on the console to find out where you spend your money through the service. So you can tweak things and try to minimize your expense you do through Amazon. So they provide you tools to do that. Elastic, what does it mean? I don't know for you, how many developers are in the room, just to guess? Not so many? Okay, so I'll tell you what I was doing before. When I had to define a server, I would have said, I'm guessing I'm going to get 100 users on it. I'm guessing they are going to upload 1 gig file every day. And I was already accounting how much capacity I needed. And when I had that guess, I multiplied everything by 10, just in case. You don't need to do that with a cloud service, and especially Amazon. You can define what you want at the fairly minimum based, and you can scale what you need as long as you're running the service. So you can always augment capacity as you run. Scalable. So you can scale all the infrastructure, and really Amazon is responsible of that. They will provide you different services you can, let's say, put together and scale your application as you need. Secure. I'm sure everyone here says, yeah, security is a big deal. And right now, you probably heard about GDPR running. They started last week. So security is a big deal. And if you're not a professional, it's always a problem. So using Amazon Cloud Service allows you to already have a good, secure stack that you can do. They won't do everything for you. You still have to do a couple of things. But they already provide you the tools to make sure that your application is securely deployed and used on the web. And finally, globally accessible. That means I work in a team which is spread through the world. I have colleagues in Japan, China, India, Canada, US, Germany. So my team is spread all over the world. And we need to share information. So you deploy in regions, you deploy on servers, and all the team can start working on develop the application using that service. Right, Tarik?
Thank you. So let me just survey the room. How many people use AWS currently? Anybody? All right, couple. How many use any cloud services currently? All right, a lot. Okay. So as Cyrille was talking about the global availability, just out of the box, it's extremely important for a number of the, not just from the information sharing, but if you look at the latest and greatest technology, if you look at the Internet of Things, those small devices have miniature amount of compute power, and they are extremely dependable on cloud to basically get the access and deliver that information. If you look at AWS, there's 18 regions around the world. Those are the blue dots. There are 4 regions that are coming, Bahrain, Hong Kong, Sweden, and a second Gov region in the US. I'm going to just talk about this quickly, but AWS regions are composed of at least 2 availability zones, and that's important because we will be showing some of the things in the presentation. But to the developer, the reason that's important is availability zones are basically geographically separated. They consist of multiple data centers. When you deploy your application, it is deployed in the multiple availability zones. So in case of volcanoes, floods, tsunamis, your application still would be available. So architecting for that high availability is basically out of the box. Like Cyrille said, we don't take care of everything, but we do take care of high scalability, high availability. So what you get with that is SLA of 99.99 availability, and you can even architect for the higher availability if you go cross regions. So having said that, let's talk about yak shaving.
Yeah, just curious. Anyone know what it means? No?
How many developers in the room first?
Yeah, already asked a couple.
And you developers did not hear of yak shaving. So how many of you do things that you think you should not have to do that are nuisance? All right, only a few?
Yeah, interesting.
It is interesting, yeah.
So yak shaving is actually a programming terms which illustrate a series of tasks you have to do for your project to move to the next milestones. And in our case, is since we talk about deploying to the web, is all the tasks you have to do to bring a simple app on the web, so your customers can use this app securely and making sure it's available every time. Tarik said, Amazon is trying to make the best to simplify your work, but actually to deploy an app could be very complicated. More, each of you in your companies have defined a process to deploy this app, and that makes the process even more complicated. So what we're trying to use on the Amazon Web Service this time is the Cloudformation system, which will allow me to describe how I want to deploy an app, and a developer who doesn't really know how to do DevOps would be able to deploy it seamlessly, repeatably, anytime, and make it, let's say, compliant with your rules to deploy. So these tasks could be complicated, and sometimes we do overcomplicate things. So this is why we call that yak shaving. 2 presentations ago, Kathy Simpson said in the Space Command Center, everyone has the same shirt. We are the same team, different company, but same team, we have the same shirt. So that's cool. So let's try to deploy that app, and we'll go into the details after. And I'm going to use my friend to do it. So even if I'm not a DevOps guy, I can have that friend to deploy the app for me in a secure way. We hope. We'll try. We'll try. So sorry if there is some glitch, but in theory it should work. Alexa, open ForgeBot.
Hi everybody, I am a super advanced conference helper who will be saving these geeks presentation today, Croatia. Thank you for having me.
Thanks. So, yeah, it seems to work. It's not finished. Alexa, tell ForgeBot to deploy Quick Start.
I can send a voice message. Try asking me to send a message.
Nah, failed. Let me try. That's my French accent, probably. Alexa, tell ForgeBot to deploy Quick Start.
Hi everybody, I am a super advanced conference helper who will be saving these geeks presentation today, Croatia. Thank you for having me.
I'm embarrassed. Let's try one more time. Alexa, tell ForgeBot to deploy Quick Start.
Hi everybody, I am a super advanced conference helper who will be saving these geeks presentation today.
You want to try?
Croatia.
Let's try with the Bosnian
Thank you
accent,
for having me.
Alexa, tell ForgeBot to deploy Quick Start.
Hi everybody,
Alright,
I am a
it's not gonna
super
work.
advanced conference helper who will be saving these geeks presentation today, Croatia. Thank you for having me.
All right, well, that didn't work.
It
You want me
doesn't
to run
like.
it manually?
Yeah, let's try. So the problem is that today, this device just understands US English. I hope it will understand French soon. I know you can also tweak accent, but on my device, I bought a German one, so it has issues. Let me try once more time while it tries through the thing. Alexa, tell ForgeBot to deploy Quick Start.
Hi everybody, I am a super advanced conference
Okay,
helper
we'll
who will be
launch through
saving
the
these
dev-
geeks
through the console.
presentation today, Croatia. Thank you for having me.
Yeah. So in theory, the device should have replied that it would deploy the example on the web through the Cloudformation API. So while Tarik is just pushing a button, which is obviously what we wanted to do, what I can do is to explain you what's going on behind the scene. So as a developer, I'm not a professional to deploy an app on Amazon Web Services. On the last time I did, took me like a day to understand how to create provisioning the machines, updating the OS, doing the API routes, provisioning the certificate for making sure we're running on HTTPS, on all these tasks. And at the end, when Tarik reviewed that, he said, I made a couple of mistakes. I won't tell which one, it's embarrassing, but it was running, but it was not necessarily very well deployed. Instead of that, one of my colleagues worked with Tarik to create what they call a Cloudformation, which is you provision every single machine, API, on everything you need to do it properly into a template you described into a JSON payload. On Amazon, when you say to the Cloudformation, deploy this, would use that payload to know which services need to be deployed, how they need to be interacting between each other, and provide you, let's say, a secured and repeatedly system using your code.
Yeah, it's not going to work because we have to trigger it by Alexa.
Okay.
So,
Well,
want
we'll
me to
see
run
later.
through it?
Yeah, we'll just go to
Yeah.
the next slide.
So, you want to go next one or?
Yeah.
All right. Right. So, what was supposed to happen behind the scenes is basically the reason I was asking you guys if you do any, if you do the yak shaving, but I can ask you differently. How often do you go to your coworker or the customer and you hear, but it worked last time, right? Or you hear, it worked on my computer, or somebody tells you something didn't work, and then they ask you, have you deployed Ziggy Libby that XYZ? And you say, no, I did not, because it didn't say in instructions. So the whole point of the Cloudformation is to basically take the whole unknown and make it known, make it repeatable, and make it easy to deploy. So when it comes to the development teams or the developers, they use Cloudformation to automate their development environments, to automate repeatable tasks. Repeatable task might be instantiating the VM, deploying the application, getting it from GitHub. Those are all of the tasks that are repeatable. Those are the tasks that add no value to you. Therefore, they treat it as a yak shaving. So you probably have to do 50, 60 of those, even if you have a CI/CD pipeline. Also, when it comes to the ISVs, so the software vendors, they can create SaaS applications and easily deploy those applications using the Cloudformation. We'll go actually through the examples of Cloudformation. Even though Alexa didn't work, there's actually a container with a Docker that I'll show you how it actually works. It's basically the same example. Speaking of that, what the Cloudformation is, if you use AWS, everything is API. So everything in AWS, when we start with API. You cannot release service without having an API. That's some of the learnings that we picked up all the way from Amazon days. And it makes things easier. So the best description of Cloudformation, it's a basically JSON template that invokes API for the creation of other services. And when I say services, those could be any of the 100 services offered, from machine learning to IoT to the VMs. In this case, we were deploying the VMs. So the way it works, basically, you start with, if this thing works, with a template here. And template is basically a JSON file. It can be YAML as well. It's your preference. That template then goes into the Cloudformation service itself. Cloudformation takes the template and basically builds the hierarchy of how tasks are supposed to be executed. It optimizes for the parallel execution. So if the virtual machine load balancer and the storage can be created in parallel, it will run those three in parallel. If they have dependency between them, it will basically build a dependency tree. So you do not have to build dependencies into the Cloudformation unless you're doing something special. Then those API calls are made to the various other services, And what you end up with is basically running environment. The running environment is basically your application that's receiving the traffic and corresponding to the users. The other things is that Cloudformation itself is free. The services that Cloudformation provisions is what you pay for. So that's just a little bit of a crash course on a Cloudformation and how it's used. So if you were doing any type of a cloud, especially AWS, make sure that you use Cloudformation. The other tools that you can use, there's a HashiCorp tool called Terraform. Terraform actually then translates into the Cloudformation. It's a pretty cool tool to use as well to do the automation. There are a number of others that are open sourced. So when it comes to the AWS, the reason I'm going to talk to you about this is actually setting the stage for when we talk about the Docker, ECS, and Kubernetes. So for those that are not familiar with AWS, you pretty much have three options to deploy your services. So you have Amazon EC2, and the best explanation of that, it's a virtual machine. So there's a physical box, hypervisor sits on it, and there's a number of virtual machines that sit on top of it. Those machines are called EC2. There's a currently family of over 10 of them. You can go from the small instances that you don't pay for that are called T2 nanos, all the way to the Bitcoin mining with the P3 instances with CUDAs and NVIDIA. So you can go from the low end to the high end of the compute. ECS and EKS, they run actually on top of the EC2. So that's basically Docker and Kubernetes. Why would you want to do that? The difference is basically the first one is virtualization of the OS, the second one is virtualization of the application. It uses only parts of OS. And then the last one, the third one, is what Alexa was supposed to be executing.
Actually, it did.
It did?
Yeah.
All right. You saw it?
Yeah, I just
Okay.
checked.
Okay. So, and I'll just then leave it at that. So I'll fast forward, and then we'll show you how it actually worked. And just as a lingo, the first one is called AMI. That's basically the image or the container. ECS is a Docker, and Lambda is Serverless Application Repository. I get this question a lot when I say serverless. People assume that there are no servers. Yes, there is a server. You just don't have to worry about it. Amazon worries about it. So that's what the serverless means. You basically take your piece of your JavaScript code, .NET code, Java code, you put it in, you only pay when it gets invoked, and the way it gets invoked is actually it runs inside of the ECS, inside of the Docker container. Having said that, you want to do this one or you want me to run through it?
Go ahead.
Yeah. So, what was supposed to happen for the non-French speaking presenters, when they talk to the audio, Alexa usually recognizes it. And then what happens, actually, Alexa talks to the cloud itself. So there's a server side of the Alexa, which does the basically.
Sorry, I'm not sure about that.
You
All
just
right.
say, Alexa,
She's not sure.
let me mute her.
So she's not sure that she actually talks to herself, which is a good thing. But it's basically machine learning. There's a number of services behind it, such as a Poly, Comprehend, Translate, Transcribe. These are all language-related services. That comes with Alexa. Then you have other services that are related to the video, so recognition could be used to basically take snapshot of the picture and recognize who is on a picture. So that goes into machine learning. Alexa basically does the speech recognition. Once she recognizes the command, you pretty much instruct Alexa to invoke the Lambda, AWS Lambda. So Alexa basically calls the serverless code. In this case, it was a JavaScript code. JavaScript code, in turn, all it did is basically invoked Cloudformation. So again, going back to everything is API. So the Cloudformation gets invoked, and then Cloudformation talks to Autodesk Forge, and you basically get your application. So at the end, this is architecture of what Alexa builds behind the scenes. So you want to go through this and
Yeah, very quickly, but I'm sure I need help because
Okay.
I'm not professional on the Amazon API. As I already said, I made a couple of mistakes in the past. So when you deploy an app on the web, usually you have to do many things. First, you need to provision machines. You need to install software you need. So here we're running a Node.js application, so you need to deploy Node on your machine. And then you'll have a server which is up and running, but not yet talking to anyone because you forgot a couple of things. First, you need to expose an IP address, or let's say a domain name, so people can say HTTPS : whatever to access your app. So you need to route internal and external API or routing calls. So you would do that through the internet gateway, and you need to do to route this through your machines and to support, let's say, millions of users. You need to make sure that you can scale or provision servers as you need. So you need to create this VPC machine that you can instantiate on demand. And for sure, you probably have a database, so you collect information or you do things. And for this, you would probably use RDS database through the Amazon. So you need to deploy per region, so you have a very, let's say, high latency response for your customers. So they're not like, if your server running only in the west region of the US and your guy is in China, he has to wait like many seconds before he gets a reply. So you deploy per region, you deploy and you replicate your data on regions. So you had fast response for all your customers. And you scale on demand, right?
Very cool, yeah. So just to touch up on a couple of things that Cyrille was talking about, one of the previous speakers was talking about improving availability of application and reliability. So I'll just add up on those. So the reason we kind of walk you through the regions, availability zones, and things like that is if you look at this dotted line here around these boxes, this is called auto-scaling group. What auto-scaling group does, it's basically a service that communicates with the load balancer. So all of your traffic to your application comes through the load balancer. And assuming, I mean, this is useful when you run the production applications. But then traffic comes in, there are always going to be peaks and valleys in the traffic. This is where basically elasticity comes through. Auto-scaling group talks to the load balancer. Load balancer basically responds with the amount of traffic that's coming through. In auto-scaling group, you define certain thresholds. So you might say, when I see my CPU going above 70%, bring up another instance or instances. So what you have here is, this is representing 4 instances, 2 Node.js servers on one AZ and 2 another. Amazon ASG would automatically bring up another 2 servers if the CPU threshold that you set is 70 and your traffic actually starts increasing. On the same token, when everybody goes to bed and traffic drops, it will actually shut down those boxes. So what that means for you and your company is you only pay for the resources that you use. You do not pay when they do not run. It's extremely difficult to achieve on an on-premise environment because you buy a box, and whether it's being used or not, you pay for that box. So that's, if you're looking for the high availability, reliability, scalability, then that's what you probably want to do.
Yeah, you don't want to maintain a server. And while Tarik was explaining how you can scale on demand, you can also protect yourself from DOS attack. So DOS attack is usually people throwing thousands of requests per millisecond just to kill your server. So you can react to that. Instead of scaling to respond to that, you can say, I also have a limit. If I see an attack, you can actually reject codes and do something else. But that's a different story. Let me ask, and you probably like me, who in this room understood everything we just explained and can do it tomorrow? Yeah, one guy. Great. 2, 3, 4. You're smarter than me. So what I want to say is, instead of trying to be the best DevOps guy and do your own deployment, you create a template, and then you become one of the best DevOps. You can deploy apps using this template on Cloudformation, making sure that you did the right thing every time.
Okay.
So this is how it looks behind the scene. As I said, it's like you said YAML, but this is JSON. So you actually, when you create this Cloudformation template, you actually work with a JSON file. So you can use JSON files, definition from another Cloudformation, modify it as you need if you want to add more services, etc. And that will define everything you need, like metadata, mapping, condition, resources, and output you need. And you can define all these, let's say, terms within the JSON file. And at the end, when you deploy, let's say, your server, you can also give a script to actually implement your app, or let's say bring your app. So here, in this example, what we're doing, we connect to GitHub, we clone one application, and we install Node.js, and we define a couple of things which are required to run Forge app on a web service, like the developer keys, client ID, and secret, which could be provisioned different way. So here it's through variables, but if you have a client ID system to provision different apps more securely, you can do that as well. So it's very flexible in the way you can work with the Cloudformation. And then at the end, you just launch your application.
Good. All right. So we have only about 7 minutes to go. So I'm going to go quickly through some of these things. I'll be here tomorrow, and I'll be around tonight. So if you want to talk to me about more detail, because I'm gonna rush through some of these slides. So I'm going to talk to you about Amazon ECS and Amazon ECR. The best way to think about these is ECS is AKA Docker. ECR is a Docker hub. The reason the ECS is there is it's a managed container service. What that means is Amazon will do the grunt work, the muck work, the yak shaving work for you, so that you can actually focus on building your application. So what that looks like is just as in any normal environment, you would start with a Docker file, and this is basically the file that contains all the commands. And I'll actually show you how to actually build the one for the AppForge viewer. And this should be ephemeral as possible. By ephemeral, what I mean is it can be stopped and destroyed. So you basically want to make this, I don't like using the term microservices, but that's probably the most compelling term. You then run the build command, which basically gives you a Docker image. Think of a Docker image as a snapshot of your application plus the minimum amount of the files that you need from operating system standpoint. Once you get your Docker image, you basically register the Docker image with the ECR or the Docker hub. In this case, it's the ECR. Then you do something that's called a task definition. Task definition is basically very similar to what we were talking about in a Cloudformation itself. It informs ECS how to deploy your Docker images. So that basically then runs, if you do the run on those, what you basically get is you get the instances of the image or the Docker containers. So at the very high level scale, that's basically what happens behind the scenes as you use the ECS. So task definition itself, we said it before, you basically specify how you want your application, how you want your Docker image to behave. You specify amount of CPU that you want the process to use, or AKA task. You specify amount of memory that you want it to use, and you basically specify any other requirements. You know, is it going to be shut down? Is it going to be recovered? How it's going to be shut down? And once you have that, you basically need to define your cluster. The best way to think about the cluster is think about it as a logical grouping of your servers. So in your cluster, you might say, I want to have a cluster of 10 servers, and on those 10 servers, on each one of them, I'm going to deploy multiple Docker images, 5, 6, 10, etc. I'm going to have 3 masters, I'm going to have 20 nodes, etc. So basically, the cluster is basically where your servers and your Docker images live. The task itself, all it is, it's basically a Docker container that runs. It's basically an instance of an image. And the other things that you need is a basically Elastic Load Balancer. Again, in the previous example, we were talking about Elastic Load Balancer informing auto-scaling group, how to basically scale up, scale down. It's the same concept with the Docker. Your ELB basically informs the Docker when to scale up and when to scale down. On a detailed scale, if you put the loop on it, it basically, what this represents is the single EC2 instance. So think of the box on the right as a single server. That single server then has 4 Docker images running in it, depicted as ECS tasks. And then on the bottom, the way that actually happens is there's an ECS agent. ECS agent is basically allowing the communication in a cluster to occur. ECS agent, the code itself, it's actually open source. So if you want to see how the Amazon does ECS, it's on a GitHub. It's basically available. You can do your own thing. You can create your own ECS images if you want, but Amazon already provides you one, so I don't know why would you create one on yourself, but you can. Docker agent is Docker itself, and ECS AMI is what I was just talking about earlier. You just basically take existing image and deploy it, and you create your cluster. That's pretty much in a nutshell what you need to do in order to be able to run ECS. We were talking about who's responsible for what, so I'm just going to quickly say this. You're basically responsible for operation in a cloud, meaning you're responsible of specifying how you want your environment to run. AWS is responsible for actually operating it. So once you specify that you want certain thresholds and SLAs, AWS services will basically work behind the scenes to meet those. So speaking of, so this is example of how I actually took the Forge viewer app and I actually turned it into the Docker and then deployed it with ECS. So starting from the top very quickly, you always want your Docker container to be quote-unquote minimalistic. I'm starting with the Node Carbon here, but if you're not using Node, if you're using more static language, you could start from scratch. So you could say from scratch and basically have a plain. Number 2 is basically where I'm putting my app. You see that I'm adding package.json. The reason for that is so that I can actually build my app inside of the Docker. And then once I added the package.json, I'm running npm install. So this first part basically builds my application image. It brings a bunch of files. It's basically my workspace in a nutshell. So it's a image 1 that I will throw away. The reason I'm throwing it away is it is the best practice to actually do the multi-stage builds, and you can do those with a Docker that's above level 1705. So the second part here is basically just a cleanup. I'm taking already pre-existing image. I'm basically moving my app in number 4. I'm exposing port 3000, and at the end I'm basically saying run my app. That's pretty much all that's required to put the app Forge viewer in a Docker. So once you have it in a Docker, this is what you do to actually deploy it in Amazon ECS, and I'll actually show you the live. I have a live demo of this. Let's see, we have 41 seconds, so quickly. All these commands you can actually get out of the console, but in a nutshell, pretty much builds the image. Number 2 basically tests the image locally before I deploy it. Number 3 basically logs into the ECS. Number 4 tags the image and actually puts it into the ECR, so now it's available for ECS to use. Number 5 deploys that cluster that we were talking about earlier, and number 6 deploys the task. That number 5 and 6, if it's not obvious, those are the Cloudformation templates. And the way it looks like, as soon as this thing comes up, is something like this. I have to switch the regions here. This is visible, yeah. So this is visible. So here's the cluster. You can see it's called 4GCS cluster. That's the name I gave it. There's one service and two running tasks. If I click on it, it will give me the details about it. It's going to tell me about the tasks. And these two tasks, these are basically two Docker images running. We'll talk about ECS instances, and they're all running. You can get any metrics that are available. And the application itself looks something like this, basically. This is ECS that's deployed. So you can see in the top bar, I don't know if this is visible or not, but let me make this bigger. It's not working. So this is not working, actually. So it is basically assigning the load balancer, and then load balancer sends the traffic between the two of the containers. And you get basically, what this is going to do, it's going to bring up the helicopter, I think. And that's basically Forge viewer that I deployed in about 25 minutes. So having said that, we're out of time. I'm going to leave you with this. There's a workshop tomorrow, which was going to be Kubernetes only. That's the reason we didn't talk about Kubernetes. So anyone that wants to talk about more in detail ECS, Kubernetes, or the Forge viewer, will be here tonight and tomorrow.
Yeah, and everything we show is open source, so if you want to grab the code, you can contact us or go on GitHub. We'll be happy to provide the source code so you can try. Thank you for everything. Have a nice evening.